which you should have numbered as 112. And let's see. Okay, so on the front page, we talked about 4 different methods to solve a quadratic. One method only works when you have x squareds but not x's. The second method is my favorite, but it only works if it factors. The third method was by graphing, but that really is only helpful if you have a calculator to graph it. And then the one where we're going to put our most focus on is quadratic formula, because that's the one that always works. So I gave you a quick example of that with 7, and you tried it once on number 8. But most of what we're going to look at today is trying to build up to some harder quadratic formula questions. By harder, I just mean that the discriminant's not necessarily a perfect square. Square root of 16 was exactly 4. Square root of 529 was exactly 23. So the last thing we did when I saw you all last is we started talking about simplifying radicals so that we can do it correctly on quadratic formula when we need to. So I did 9 through 16. I believe I asked you guys to do these 4. Is that correct? Do you have those 4 done on your paper?
Yep.
Okay. So give me just a second here, and I will tell you what I think the answers are. 5, but I'm doing these in my head, so if you disagree, just speak up real quick. Square root of 5, maybe. Plus 2 square root of 21. Okay, is that what you got for the 4? All 4 of those look correct to you?
Yep.
I did them real fast, so there's a good chance there's a mistake. I just did them right now. Okay, if you did not get one of those answers, just jot it out to the side, circle it, and go back and try it again later. Okay, and then I think we finished up with, we started talking about if there was a negative under the square root, so just going one more step with it. Always bring out the negative as an I, and then simplify the same way. Square root of 4 is still 2, square root of 9 is still 3, square root of 81 is still 9. Did I have you do 26, 27, and 28? Did I ask you to do those? No? Okay. Then let's go ahead and let me do 3 more examples for you. You can just copy those 3 as notes, and then I'll have you try the last row as some practice. But again, we're going to need this for the next page, so I'm just trying to let you focus on this one skill before we throw it into the mix here. Okay, so if you have a negative under the square root, just instantly take it out as an I, and then that part is finished. You should still try to simplify the square root of 28 the same way. You've got some options, but again, I prefer what's called prime factorization, which you get from the factor tree. So instead of saying 28, I would say 2 times 2 times 7. And since this is a square root, I need 2 of the same things to group up and come out together. So in the end, there's a 2 and an I out front, and a 7 left over. Now, by the way, if you try to put that in your calculator, it's going to give you an error message. It's going to say non-real answer error, and it's trying to tell you that that has something to do with imaginary numbers, and our calculators are just not programmed to do much with imaginary numbers. I'm sure they could do more, but if calculators do too much, then they become unfair for the ACT and stuff, so they have to limit how much they can do for you. Okay, so 72, again, just instantly pull out the negative as an I so you don't forget about it, and then break down the 72 the way you normally would. 72 is not a perfect square, so what I would do is factor tree, 2 goes into it evenly, and then even though 6 is not really prime, I can see that 27 is the same thing as 2 times 6 times 6. So the 2 6's under can come out as 1 6 out, 6i square root of 2. Now, even though I did just say that your calculator can't do this for you, it can almost help you check. I did mention this on a previous question. But again, if you say, ask your calculator, what's the square root of negative 72? It's not even going to try. Non-real answer. But you could say, well, what is just the square root of 72? What is 6 square root of 2? And if those are the same, and you're just making sure you're pulling out the negative as an I, again, that doesn't guarantee you simplified it completely. You might have brought out some stuff, but not enough. But it does guarantee that I didn't change my answer. So sometimes if you have a calculator, you can do that. Okay, square root of negative 150. Again, just pull out the I, be done with it. 150 could be like, I don't know, 10 times 15, which is 2 times 5 and 3 times 5. And if you have 2 of any number, let them group up and come out front. Everything out front gets multiplied together. Everything left behind gets multiplied together. So I'm going to freeze my screen here, and I'll give you a couple minutes to try the bottom 4 here. So I'd like you to try them before I show you my work and see if, just make sure you don't have any questions, because again, this is going to get tied into the quadratic formula, and you don't want to have to be struggling with this step of it to move on. So please do 25 through 28 in the next minute or two.
For this, I left over there, but
Oh, sorry, I maybe didn't put enough out. I'll get it for you. I did these, they tried those, and we went over them together, and then I did some of these, they did some, yeah, and this is where we're at, and then this page goes with it too, but they haven't started on it. All right, here's what I've got. I didn't quite finish each of the questions, but I've got them all set up. So notice for all four, I pulled out I in red. Just do that before you forget. I did the factorization. So in 25, you should have brought out a 7 to end up with 7i square root of 2. Number 26, you could have brought out a 2, which leaves you with 2i square root of 15. Again, anything that comes out gets multiplied together, anything left behind gets multiplied together. 27, you could bring out a 2 and a 3. So you've got a 2, a 3, and an I, which makes 6i outside and 5 left inside. And then notice on 28, I noticed that I'd already done this part of the factor tree, so I didn't have to do it again, if you were paying attention there. You could pull out a 3, so 3i square root of 10. That's what you were aiming for there. Okay, so again, we did 2 quadratic formula questions together last time, and the discriminant, the stuff under the square root, was a perfect square, but sometimes it's not. Sometimes it's not a perfect square, and we need to just simplify it like 9 through 20 to move forward. And sometimes the discriminant's negative, which gives us imaginary solutions, and we need to be ready to simplify like we just did 21 through 28. So all of that was really for this. So the next page, this one might be the most important because this is going to try to slowly push you towards the messier quadratic formula questions. I have it as easy as possible and then slightly messier the next 2, and then slightly messier on the next 4. Although I think 2 of those actually aren't that bad. Okay, so the steps of the quadratic formula. Again, you need to know what A, B, and C are. I don't know if I really consider that a step, but you better make sure you memorize the quadratic formula correctly. We will 100% put quadratic formula type questions on your next test, and if you memorize the quadratic formula, you're going to miss out on a handful of points. Of course, if you show me your work and stuff, I'll still be able to give you some partial credit, but it's going to hurt when you get partial credit every single question that's like that. Okay, so looking at 29, again, this one should work out as nicely as possible. I can see that A is 1, B is negative 10, and C is 11. So I'm going to just plug those in as the quadratic formula says. Take the opposite of B plus or minus the square root of B squared. Now, if you're going to put B squared in your calculator, you better put it in parentheses. If you do this, this is a very common error that you guys do. If you're not sure what negative 10 squared is and you do that, that's not what quadratic formula says. Your calculator does order of operations very strictly. It does the squaring before the multiplying by negative 1. What you mean to do is this. All of B is squared. Makes a difference. So be careful with that. Okay, minus 4 times A, plug in 1 for A, times C, plug in negative 11 for C, all over 2 times 1. Now, this just depends on how messy the arithmetic is. We're going to try to do all of these without a calculator, but if the arithmetic's super messy, then we'll just fall back on the calculator. I can do 2 times 1 in my head, no problem. Right here, I've got 100 minus a 4 times a 1 times a negative 11. A minus a negative is like plus. 4 times 1 times 11 would be 44. So the discriminant comes out to be 144. I'm going to highlight this step because that's where the majority of your mistakes are going to happen. You need to be careful with the arithmetic there. A lot of times you guys don't keep up with this sign or this sign, and you subtract a number from 100 instead of add a number to 100, but you need to be careful there. Now, the reason why this one simplifies so nicely is the square root of 144 is a perfect square. If you don't know that, you can still do the factor tree, and you'll discover that 144 comes out to be exactly 12. And so that's just an easy radical to simplify. So that makes the ending of quadratic formula nice as well. One answer comes from 10 plus 22, or 10 plus 12 over 2, and the other one comes from 10 minus 12 over 2. These reduce to 11 and negative 1. I think that might be the same question we did on the front page, but we did it with factoring or something instead. Again, I would always factor. I just said I'm trying to get you to practice quadratic formula. So in a few minutes, number 30 should be about the same difficulty. The discriminant should be a perfect square, so the end of the question should be as straightforward as it can be. Okay, let's skip down to 31. Again, I'll give you time to try each of these after I do an example. But once again, the same first couple steps. You better know where A, B, and C come from. You better have the quadratic formula memorized. My suggestion there is to just quiz yourself on it each question, make yourself write it down each time, and check it. And then eventually you'll just get it from repetition. But it says opposite of b, which would be positive 1, plus or minus the square root of b squared. Negative 1 times negative 1 would be positive 1, minus 4 times a times c all over 2 times a. So the easy arithmetic is on the bottom. 2 times 5 is going to be 10. And this part I'm highlighting again because this is where you need to slow down. Every year it's the same thing. This is where too many arithmetic mistakes are made. Now, feel free to check it with the calculator, but again, please try to do it without a calculator too. 5 times 5 would be 25, times 4 would be 100, 1 minus 100 would be negative 99. So why I'm saying this one is harder than question 29 that I just did for you is negative 199 is not a perfect square. So you need to know to bring out the negative as an I, simplify the square root of 99 in whatever way works for you. I'm going to do factor tree. Square root of 99 ends up being 3 square roots of 11. And that's as far as we can go on that question. One solution to this is 1 plus 3i square roots of 11 over 10, and the other solution is 1 minus 3i square roots of 11 over 10. You can't simplify those anymore. Nothing else you can do to that. Okay, so if I remember correctly, 32 should be about the same level of difficulty. You actually have to simplify the radical like I did, but then you should be finished. Okay, branching out one more step. There's just one more thing that you could possibly do to make it a little bit more work to simplify. Let's do 33 and 35 as examples, and I'll have you try 34 and 36 for some practice. Okay, so first part, it's no different. Don't overcomplicate it. A, B, and C. Now, I guess I should say this. A, B, and C are the coefficients of x squared, the coefficient of x, and the constant. But they do need to be all on one side set equal to 0. If like this 9 was over here, you need to subtract it over before you identify what C is. If there was a plus 9 here, C would actually be minus 9 because you'd have to subtract it over. A, B, and C, everything has to be on one side, either the left or the right, doesn't matter. Okay, plug in the stuff like the formula says. Opposite of b, plus or minus square root of b squared. I know what that is, so I'll just go ahead and change that. Minus 4 times a times c all over 2 times a. Alright, quick and easy step I can do is the 2 times 1. The one that I'm worried about that you need to slow down on is the discriminant, the stuff under the square root. 4 times 1 times 9 would be 36. So 100 minus 36 would be 64. Okay, so this one actually isn't bad. Because 64 is a perfect square, the next one should be messier. It comes out to be exactly 8. And then keep going with your last two answers. negative 10 plus 8 over 2, and negative 10 minus 8 over 2. So also keep in mind that if we put this on the test and said do this using quadratic formula, you'd have to do it with quadratic formula, but you could also do factoring out to the side and you would know what answer you were aiming for. So okay, so that one kind of misses the mark. That's not what I was going for here. So let's do 35. This one should. Okay, A is 1, B is 2, C is 7. Put them in the quadratic formula just like it tells you to. You really shouldn't be putting too much thought into the first couple steps. You're just doing what it tells you to. Even when you get to this point, 2 times 1 is going to be easy. This, I want you to slow down and be careful on, but it is just arithmetic. So 4 times 7 would be 28. 4 minus 28 would be negative 24, which is not a perfect square. So we could bring out the negative as an I. We could break down the square root of 24. Square root of 24 becomes 2 square roots of 6. Now, here's the last step that I am concerned about you guys might not recognize. You can go one more step here. Just based on how this radical simplified, this didn't happen. Well, that one was kind of a bad question. This didn't happen here. It didn't need to be done, but there's still one more thing that needs to be happened here. So this, I'm going to highlight these terms. This, maybe. What's this, 2 square root of 6? Okay, this term, and this term are all divisible by the same thing. Just like you wouldn't leave a fraction 2 over 4, you would go ahead and divide both of them by 2 to reduce it. If this is divisible by 2, and this is divisible by 2, and this is divisible by 2, then you need to divide everything by 2 to reduce your fraction. So negative 2 divided by 2 would be negative 1. 2 divided by 2 would be 1. And 2 I square roots of 6 divided in half would be 1 I square roots of 6. The I square root of 6 is just what it is. And of course, putting it over 1 doesn't really do anything, so I wouldn't leave that as part of my answer. So let me write that one more way just to help you see. It might help you see why you need to do that, or why it works. So remember, bless you, with fractions, you can always split apart numerators but not denominators. So if I put this over 2, plus or minus, and then I put this over 2, you would definitely reduce this to negative 1, and you would definitely let these two cancel and leave you with I squared root of 6. So if it makes more sense to you to split apart your fraction and then reduce each one, then do that. But in the end, it's the same thing. If this term, and this term, if all the terms are evenly divisible by something, you need to divide them all by that. Just like 2 and 4 are both divisible by 2, so we'll divide them both by 2 to reduce. This is technically equivalent, but it's not simplified correctly or completely. So again, it just depends on what the discriminant is. The discriminant determines how much work and how messy your answers are going to be. But if your discriminant's a perfect square, should work out great, like 29. Your number 30 should be similar. If the discriminant is not a perfect square, you're going to need to simplify your radical, like we did in 31. Your 32 should be similar. And I don't know, 33 was not the best example, but 35, not only was the discriminant not a perfect square, but after I simplified it, the whole fraction simplified also. So you have to think about that to know if it's completely finished or not. So definitely your 36 should be the same. Your 34, I think, is also the same. So those are the ones I need you to practice next. So look at what we did on 29, try it out on 30, try to use your calculator as little as possible. Then look at what we did at 31, try it on 32. Then look over 35 and try it on 34 and 36. So that would be 4 questions total. So let's aim for about 10 minutes. 10 minutes, and then we'll make sure that we're all up to speed there. please try to get caught up with everybody else in 2 minutes. Alright, so I will tell you for the back page, a good way to check your answers. I guess I should have probably told you that up front here so that you could have checked these and known that they were okay. But that's okay, it'll still just take us a couple minutes to go over them. So I know where A, B, and C are coming from. I have quadratic formula memorized. I'm not going to write it out again, but I do have it written up here. Just trying to zoom in for you. So your first step should look like this. Opposite of B plus or minus B squared minus 4AC all over 2A. Again, you're just doing what the formula tells you to. You're not really putting any thought into it at that point. 2 times 1 is 2. This part's called the discriminant. Be extra careful here. 4 times 1 would be 4. Times 21 would be 84. 100 minus 84 would be 16. That's one I think you should probably be able to do without a calculator. And now this is on the easier side because square root of 16 comes out to a perfect 4. So one answer is going to come from 10 plus 4 over 2. And one answer is going to come from 10 minus 4 over 2. Looks like you should have gotten 7 and 3. Everybody okay with that one? Okay, your next one, the determinant should have been a little bit messier, but first few steps are the same thing. Opposite B plus or minus square root B squared minus 4 times A times C all over 2 times A. If you know quadratic formula and you know where A, B, and C come from, that's all the time you should need to get it set up. So I can do 2 times negative 1 in my head, not a problem. But this I'm going to slow down quite a bit on. In fact, I'm going to make one extra step here because I'm afraid I'll mess this up too. This would be 4, okay, a negative times a positive times a negative times a positive. It's going to be positive. 4 times 1 would be 4. Timesing by half is the same as dividing by 2. So that comes out to be 2, which means the discriminant was 18. So the only thing that makes this harder than the one I just did is square root of 18 is not a perfect square, and you've got to know how to break down the square root of 18. Looks like it is 3 square roots of 2. 3 square roots of 2. And in this question, that's all you can do. I know it's not pretty, but there's not any more simplifying that can be done. Nothing divides evenly into -4, 3, and -2. So this fraction does not reduce. I just had to be able to break the square root of 18 down in comparison to the last one. Okay, whereas 34 hopefully makes you go one more step. Hopefully at least one of these two did. So opposite of b plus or minus square root b squared minus 4ac over 2a. Denominator becomes 4. The discriminant would be 16 minus 8, which would be 8. Square root of 8 is like 2 square root of 2. And now here's where this one goes one more step than the last two I did for you. This term, -4, this term, +4, and this term, 2 square roots of 2, are all evenly divisible by 2. So you should divide everything by 2 to reduce this. This divided by 2, this divided by 2, and this divided by 2. You don't also divide the stuff under the radical. A square root of 2 is what it is. I had 2 of them, so if I divide it in half, now I have 1 of them. Now again, you're also welcome, I just don't tend to do this, but you could always split apart the fraction. You could put -4 over 4 and put 2 square root of 2 over 4, and I don't know, that might help you see how to simplify it a little bit, but I tend to just try to divide everything by the same number. And that's as hard as quadratic formula can get. So one last time, opposite b plus or minus square root b squared minus 4ac over 2a. Denominator becomes 10. The discriminant is, I don't know, yikes. This would be 10, 40, 36 minus 40 would be -4. So square root of -4 is going to simplify to 2i. And even though this, you can't always do this, the previous section we couldn't do that on these questions, but 2i, 10, and 6 are all evenly divisible by 2. So you need to divide everything by 2 to reduce your fraction. Now, there is, I'm going to come back to this one in just a second to show you how to check, but we're going to skip the back page for right now. I'll give you the end of class to do some of those. But at the end, it just got 6 practice questions, but one thing that's a little bit different, so let me point this out because the previous questions didn't have this as an issue. You should not call this A, C, and B. A, B, and C can only be identified when everything is on one side set equal to 0. Add this one over, add this one over, or add that one over. It doesn't matter what side you go to, but before you say what A, B, and C is, you need everything on one side. That did not come up to the last 6 questions. Finally, I know some of these last 6 have some kind of weird looking answers, and I don't want you to just cross your fingers and hope that it's correct. I would like you to actually check your answers. So even if your answer is imaginary, your calculator can check these. So this is where I'm coming back to question 36. I'm going to ask my calculator, is 3 plus I over 5 a solution to this? And is 3 minus I over 5 a solution to this? So if you go to your calculator, it does have I programmed in. It's not this I. The I above the x squared button, this is like if you're typing a message out. The I, the number I, is above the decimal. You have to hit second. Let me do plus first. You have to do second decimal to get the number I. Okay, if I think that is a solution, if you use the store button we've talked about a few times this year near the bottom left, store that in for a variable like x. And if it's really a solution, it should make 5x squared minus 6x plus 2, 5x squared plus xx minus 2. It's supposed to make it equal to 0. And it did not, so I didn't do something correct here. 3 plus I over 5. Oh, it was supposed to be minus 6. All right, well, that's still good for you to see. It didn't give me 0 because that wasn't the solution. That wasn't the original equation. That's supposed to be 0. Okay, that's not 0. So, I'm sorry? Oh, it's a plus 2? Sorry. I don't have the hard copy of the paper up here. I try to not flip back and forth this much. Okay, but now it actually works. So now that x thinks it's one of my solutions, even if your solution's imaginary, notice it made the original equation equal to 0. And imaginary zeros always come in conjugate pairs, but if it makes you feel better to store the other answer and check the original equation again, it only takes an extra 10 seconds. So if that makes you feel better, not only did 3 plus I over 5 work, but 3 minus I over 5 also worked. Also equaled 0. So that's what I'd like you to do with the last 6 to check. But before I give you time to do that, let's look at today's handout. So the other quadratic stuff that you need to know. I think a lot of this is going to be very straightforward to you, but maybe there's a few things you've forgotten about. This handout's really only 2 questions, but we're going to kind of break it down and talk about everything about this graph. So I'm going to do the top half of this for you and ask you to do the bottom half. So this will be the last part I guess I need to show you today. And then you can have time to do those others. Okay, so over here, this one says write in factored form. So, of course, factored form is where you're trying to factor it. If it has a GCF, you should pull out a GCF first. And then to factor, if you want to do product sum instead of guess and check, that is perfectly fine. But factored form just means factor it. This is what most people call standard form, although some books kind of switch up the names a little bit. Okay, there's also something called vertex form, and that's one that you may not remember very well, but we'll come back to it after we have some of this information. So, y-intercepts, just like all other math stuff, happens when x is 0. So if I plug in 0 for x and solve, I know the y-intercept is going to be at 0, negative 12. This a value tells you if it opens up or down. If a is positive, your parabola is going to open up like x squared. But if a was negative, it's being flipped over the x-axis at some point and opening down. So this one, a is positive 2, which means it's opening up. And this bottom point is what we call the vertex. The bottom point or the top point is the vertex. Since this one's opening up, the vertex is a min. Now, for vertex, to actually find the vertex, there's a few different ways you can go about this, and I'll mention a second way in a minute. But the kind of the preferred way to do this is there is a formula for the x value. The x value of a vertex is negative b over 2a. It's really just the far left part of quadratic formula. The first part of quadratic formula is negative b and then plus or minus some stuff all over 2a. The far left of quadratic formula will give you the x value of the vertex. So that would be 2 over 4 or a half. And if you know the x value of the vertex, you can just plug it into the function to get the y value. And I'm going to just do that in my calculator real fast. to try to give you more time here. This is negative 12.5. But a vertex is either the highest point or the lowest point. Since this one is opening upwards, it's a low point, and that low value, the min value, is the y value of the vertex. That's how low this graph is going to go. Whereas the line of symmetry is the line that cuts your parabola in half, and to go exactly in the half, it's going to need to go through the vertex. So x equals, because it's a vertical number, or a vertical line, and again, to split your graph in half, he needs to go through the vertex. So getting the vertex, the x value gives you the line of symmetry number, and the y value gives you the max or min of the function. You get a lot of information out of the vertex. Okay, the x-intercepts, I would probably use the factored form over here. X-intercepts are when y equals 0. So if you already have the factored form, I mean, I guess you could do quadratic formula like we just practiced, but if you're having to do factored form anyway, set 2 equal to 0, that doesn't give you anything. Set x minus 3 equal to 0, you get one answer. Set x plus 2 equal to 0 and solve, you get the other answer. Okay, now let's talk about the vertex form. This is one I feel like you might need to add a little bit to for reminders here. Vertex form looks like this. Where HK makes up the vertex. Okay, there's only going to be 3 numbers we put in here. We're going to put a number in for H, K, and A. HK makes up the vertex. So the x value of the vertex goes in for H. It says minus it. And the y value goes in for K. It says add it. So this one, the signs look a little bit off. You need to make sure that that makes sense to you. You're supposed to subtract the x value vertex, but add the y value of the vertex. It's just how the form's set up. Okay, the a value is the easiest. A, the reason they use a in this form is it's the a that you're used to calling with quadratic formula. A is going to be a. So 2 is a, so plug in 2 for a. Just a different way to write the equation. It just kind of depends on the context of the question. If I really care about the max point or the min point or where it's occurring, vertex form's a little bit nicer. Now, I did say that there was one other way you could find the x value of the vertex. So the vertex, it has to be in the middle of the question. So if you average your 2 x-intercepts, the average of 3 and negative 2, you would get 1/2. The vertex has to be in the middle of the graph. So the x value of the vertex would be the x value that's in the middle of the x-intercepts. So that would be another way to find the x value of the vertex besides negative b over 2a. Okay, so now we got a ton of information that they're asking us to throw on a graph here. I'm going to put the x-axis up a little bit higher because I know it goes down to negative 12.5. So we could graph the y-intercept, 0, negative 12. 6, 7, 8, 9, 10, 11, 12. I could graph the vertex. I could graph the 2 intercepts, x-intercepts. I don't know, the directions say graph the function with 5 points from above. Oh, I know where one more point will come from. You don't have to, but you could graph the line of symmetry as a dashed line. It's called the line of symmetry because it divides your graph exactly in half. So if you thought an x-intercept was here, but you didn't think this x-intercept was here, you thought it was over here, that wouldn't make sense because this is supposed to go through the middle. So it needs to be equidistant from the x-intercepts. This also helps you with more points because this point down here, I know I could flip him over the line of symmetry to get a 5th point. That's where they're saying you should be able to get 5 points. This point flipped over, this point flipped over, and a point on the vertex, you can't really flip it over. It's just going to stay there. All right, now we've got plenty of information to connect them. And to finish, the last things we may ask you about is, when is the graph increasing? So that's when is it going up? Not how far down to how far up, but when, which implies x values. He starts going up when x is a half and goes up forever to the right. Decreasing is asking you, when is the graph going down? These are big concepts in calculus, by the way. So when he's going down is starting at the far left until he gets to x equals a half. And for your equation to be constant, it would have to be flat for a while. That's not going to happen on quadratics. Your graph's either going down or up. Down to the vertex and then up after, or up to the vertex and then down after, depending on which way it goes. So again, I know that's a lot of information, but most of that should be pretty familiar to you. So let me try to put all of this up here on the board so that you can finish copying down what you need to. Okay, and we've got about 20 minutes left. So to make sure you guys are on the same pace with my other classes, I'd like you to do those last 6 quadratic formula questions, check them in the calculator, and then try this one more graphing on the bottom. If 20 minutes isn't enough time, that's okay, but please do that for homework. This is a B week, so I won't see you again until Monday, so you should have plenty of time to wrap those 2 up, and all of the classes will be at the same place then. Of course, if you guys do find a question you'd like to ask about while you're here, then go ahead and let me know. Otherwise, this is the extent of what we expect you to know about quadratics. This graphing stuff, the different forms, and being able to solve a quadratic. But technically, if you can do quadratic formula, then you can solve any quadratic. So